This is Mr. Wright. Today we're going to talk about how to set up a proof to solve for congruent triangles. So when we are setting up a proof, this is called a two-column proof. On the left side, you're going to have statements. On the right side, you're going to have reasons. When you start off a proof, you start with kind of like what's given. Then you have the body. Then at the end, whatever it is you're trying to prove. And you always number your steps. So let's just look at an example. So first steps, this is what's given. So those are the first two steps I'm going to write down. Whatever I just wrote down, that's given. So right there, and now you write given as the reason. So in a proof, every single time you write something down, there has to be a reason for it. So after we write down the givens, if I look at my picture, the other thing I notice is that I have vertical angles. So if you have vertical angles, you write that down. So that's step 3. So those two angles are congruent, and you write vertical angles. And then the last step is always going to be what you're trying to prove. So in this example, I'm trying to prove that these two triangles are congruent. So I can now prove that. So you actually write that down. Whatever this says, that's what you write down. Whatever this says, that's what you write down. I can prove that because if I look at my picture, I have angle, side. So like one of my 5 triangle congruence rules. So some different things that'll pop up. So we already talked about the vertical angles already. So that was the vertical angle. So if you have vertical angles, you write your congruent statement and you just say vertical angles. Another thing that could pop up if you have a midpoint, like that's going to be given. So you say that it's given, but then you also have to come up with another piece of information. So like these two segments are going to be equal because of the midpoint. Okay, so if you have a midpoint, you still need to come up with that congruent statement, and then you write definition of midpoint. It's kind of like the same thing for a bisector. You could have a segment bisector or an angle bisector. So that's going to be given to you, but then you need to come up with that congruent statement based on what's being bisected. So if line LJ is being bisected, then this piece is congruent to this piece, and you need to write that down and say definition of bisect. Or if the angle's being bisected, then these two angles are going to be congruent because of the definition of bisect. Just a couple more things. Another thing that's going to come up is if you have a shared side in a triangle. So like this would be my shared side. So you just write that side is congruent to itself, BD is congruent to BD, and the reason is always going to be RPC, which stands for the reflexive property of congruence. And then another one that's pretty common is when you have parallel lines, the alternate interior angles are going to be congruent. So this would be those red spaces right there. These would be alternate interior. So you just write those two angles are congruent because they're alternate interior angles. So whenever, pretty much like as you're doing proofs, whenever there's something that's congruent, you add that to the picture. You need to also write down a statement at the same time. Let's just do a couple proofs together so we can figure out how to do them. Let's look at 28. So the first step is you always write down the two givens. So we number our steps. Number 1, AB is congruent to DE. The reason is it's given. So after I write that down, A, B, and DE, I'm going to add that to the picture. The next thing that was given was angle A and angle D are congruent. And I say given, that's the reason. Let's add that to the picture. Angle A and angle D are congruent. All right, so now that's everything that was given. Now I need to figure out, is there anything else I can add to the picture that would also be congruent? So in this situation, I notice that I have vertical angles. So I actually need to write that down. That's going to be the next step. I need to say angle BCA is congruent to angle ECD. So those two middle angles are congruent because they are vertical angles. So all of these problems, what we're trying to do is we're trying to prove that the two triangles are congruent. So that's going to be the next step. So the last step I was talking about angles. This step I'm going to actually talk about triangles. So triangles, so now I actually have enough info to prove that these are congruent because of angle, side. So I'm going to say triangle ABC, so you're just using your 3 letters, and you match up the other side the same way. The triangle ABC is going to match up with DEC because they're congruent because angle, angle, side. So we just did that. If you look at the marks, it's angle, angle, side. So the 2 triangles are congruent because of that. Now this example, we want to end with this step. So that's going to be the last one, 5. BC is congruent to EC. So whenever you have like a piece of information like that as the last step, you first have to prove that the 2 triangles are congruent, which we just did. Then the last thing is if the 2 triangles are congruent, then all of the other matching parts are also congruent. So these would be congruent because this is the last thing in your flip book, CPCTC. So that stands for corresponding parts of congruent triangles are congruent. So that's right up here. Corresponding parts are congruent, triangles are congruent. So first you have to prove that the triangles are congruent, like we did. Like that would be kind of like the example that we just looked at. And then that's your last step. So first the triangles are congruent, and then you do those other pieces are congruent because CPCTC. So that would be an example of, we would need like vertical angles. Let's look at another example. Let's just do this one because there's a couple of different things that's going on. So first I'm going to write down my 2 givens. LM is congruent to JM because it's given. And I'm going to add that to my picture, LM, JM. So if you're going to add something to your picture, it has to be written under as a statement, like those 2 pieces are congruent. Next thing is KM bisects LJ. Okay, so I know that, so the one thing students kind of get confused on is like which one is being bisected or split in half. So LJ is the one that's being split in half. So I know if LJ is being split in half, then if this is LJ, then this half is equal to this half. Okay, so that's what, whenever you have a bisector, you have to figure out what 2 pieces are equal, and then you actually have to write those down. So that means that LK and JK are congruent. LK is congruent to JK, and the reason was because of the bisector. So what we actually have to write is definition of bisect. All right, so we have the bisector. Now, if I look at my picture, the other thing I notice is that they have a shared side. So that side is always congruent to itself. So when you have this type of situation, I would do KM is congruent to KM. So that side just equals itself. You just do the same 2 letters twice. And the reason, so this one is our reflexive property of congruence. So you write RPC. So whenever you have a shared side, you do RPC. And now I have enough info if I look at my picture to do side, side, side. So I'm at the point where I can say that the 2 triangles are congruent. So I'm going to do LKM, triangle LKM is congruent to triangle JKM because side, side, side. And that's what we were trying to prove. So that's the last step, and we're done. So you want to get to a point, so you always start off with your givens, and then you want to get to a point where you can do one of your 5 triangles rules, like side, 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 angle, side, angle, one of those rules. So then once you have the triangles congruent, that might be the last step, or you might have like one more step after you do that where you would have to do CPCTC. So those are 2 common situations. So we went over the bisector, we went over the shared side, we went over vertical angles. The only other thing that sometimes may come up is you may have parallel lines. If you have parallel lines, like in this example, then the alternate interior angles are going to be congruent. So like in this example, angle B and angle D are alternate interior. So you would have to write that those are congruent because they're alternate interior. Or A and E are also alternate interior. So really there's two sets of alternate interior angles in this example when you have parallel lines. So I know they're parallel because of these arrows. So that's how you do proofs.